So we worked through the distinct linear factors case. Let's work with the repeated linear factors case. Repeated linear factors case. So an example of the repeated linear factors case is problem number 30. X minus 4 over 2x minus 5 quantities squared. Well, this is different than, say, problem number 22, because you don't have an x and a 2x minus 1. You've got this thing twice. And the way the setup on this kind of thing works is we'll do a over 2x minus 5 to the first power, and then b over 2x minus 5 to the second power. Now, had this been a third power, then I would have had another term plus c over 2x minus 5 to the third power, and so on. However high this is, you're going to have terms on the right-hand side of this decomposition starting with 1, 2, 3, all the way up to whatever this is. Now, solving this is kind of almost require working it the way we did originally, which is with a system of equations. Let's start that process by multiplying through by the lowest common denominator. That LCD is going to be 2x minus 5 squared. So that has to distribute itself to all three terms. When I do, I'll get x minus 4 equals a times 2x minus 5 plus b, which isn't too bad of a system of equations that it's going to lead to. So let's see here. It's going to be x minus 4 times 2ax minus 5a plus b. Now see if you can't line this up and determine your system of equations. Keep in mind that out in front of the x here is a coefficient of 1. One of the things that I'm likely to do is set up a problem for you that asks you to just give me the system of equations, and then we'll worry about solving it later. Because when you have this repeated linear factor, you have to have you have to have terms up to and increasing till you get to that order. So like I said, if this was a 4, I'd add this to the first power, second power, third power, and then fourth power. You have to have one of each. Now, it can and often does turn out that some of these are 0, and that's okay. But you have to account for each degree in increasing order. How about the first equation? What do the coefficients of x say about what's going on here? What's the first equation that I can get? Yeah, 1 equals 2a. Now the next equation, you have to be a little bit more thoughtful. Negative 5 plus b, that's your constant term. Now why is your constant term? Well, it doesn't involve the x. So I get another equation from that. What's that second equation? Negative 4 equals negative 5a plus b. Cool. Now you can solve this system any way you want. I mean, this one's pretty straightforward. You can multiply through by 1/2 and get 1/2 for a. If a is 1/2, negative 5/2 plus b. So what, negative 3/2 for b? Thank you. So I'm pretty sure we get negative 3/2 for b. So what's that mean for our solution? That means x minus 4 over 2x minus 5 decomposes into 1/2 over 2x minus 5 to the first power minus 3/2 over 2x minus 5 to the second power. Now what you might see done, depending on the author or whoever's writing the answer key, you might see these fractions brought down so that the 2 is going to multiply in the denominator. I'll have 1 over 2 times 2x minus 5 minus 3 over 2 times 2x minus 5 squared. You can distribute the 2 here. You can't distribute the 2 here. You'd have to FOIL that out before you distribute the 2. I'd accept either one. Frankly, these problems are long enough that I'd suggest you just leave it like this. But whatever works for you. Okay. How do I get what? I added 2.5 to both sides. So negative 4 plus 2.5 would be negative 1.5, which is negative 3/2. Because I want to get b by itself. So if I add positive 2.5, that'll cancel this out. And then 2.5 plus negative 4 gives me negative 1.5. Anything else on this one? Let's try problem number 34. And 34, let me just politely say that 34, when I was preparing that problem, motivated me to release a torrent of profanity towards the author. Wasn't happy with that one. Although it does have a lot of good review parts in it. So let me talk a little bit about the review parts in it, and then we'll actually go through some of the work. If you'd like, what I'll do is I'll post, in fact, I will put my notes into the notes that get scanned in on D2L. That way you can kind of follow along. But just try and follow along a little bit without necessarily trying to keep up with all the notes. You won't be able to keep up with all the notes. Problem 34 looks like this. Negative 2x to the second plus 5x minus 1 over x to the fourth. Yeah, thank you. X to the fourth, where is it? Minus 2x cubed plus 2x minus 1. And like I said, I'm going to use this as an excuse for review. I would not do all this to you on an exam problem. It'd just be way too much, over the top. So, what do we have to do to start here? We have to factor it. And you look at the denominator and you try factor by grouping and you're like, wait a minute, it doesn't factor. So now you're really stuck. You're like, okay, well, I don't get it. It doesn't factor. So what can you do? Well, we can look at the graph. You should know that there's a correspondence between roots and factors, right? So let's go to Desmos and see what Desmos can tell us. So we have y equals x to the fourth minus 2x cubed plus 2x minus 1. Okay, so there's our graph. Let me make it a little bit easier to see. So where do we have roots? Negative 1 and 1. So let's think a little bit further about these roots here. So let me cut back over to this. I've got roots at x equal 1 and x equal negative 1. Let's take a look at the behavior of those roots. So at x equal negative 1, what kind of behavior do we get? Straight through. Straight through. And at x equal 1, what kind of behavior do we have? Wiggle. All right, so if I've got straight through, what kind of multiplicity does that imply? A 1. If I've got a wiggle, what kind of multiplicity does that imply? 3. Have I accounted for everything that I need? Yeah. I've got 4 different, I've got a total of 4 roots here. Degree is 4, so I've got everything I need. Now, let's look at the corresponding factors. If x equal 1 is a root, what's the corresponding factor? X minus 1 and likewise x plus 1. So this can be written in factored form. It's going to be x plus 1 to the first power, and then x minus 1 cubed. So it's a nice extra little bonus step that you get for free, courtesy of the author. Yay. All right, but it wasn't bad to review those things. So, all right, well, let's look at the setup then. If I want to do a partial fraction decomposition, here's where it gets long and messy. So it's going to be negative 2x squared plus 5x minus 1 over x plus 1 times x minus 1 cubed. And let's start out with the first term as a over x plus 1. What else do you think I'm going to need in my partial fraction decomposition? Good. B over x minus 1. Higher, higher, higher. Anyone else? C over x minus 1 squared. Still higher. Wow. Glad we have some technology available. This one's going to get messy. This one gets really ugly. In fact, I would recommend that at this point you put your pens down and just kind of watch it all from here. And I'll put this exactly into the notes. In order to solve for 4 unknowns, you're going to need 4 equations. Woo, Tyler's pumped about this, man. He's going to tweet about it when he gets home. 4 equations and 4 unknowns. Yuck. So let's see here. We'll start up here. I'm going to multiply everything through by the LCD. The LCD is just this denominator over here. Now you're going to get a lot of cancellation. And that's going to look like this. So you get a times x minus 1 cubed plus b times all this stuff. And wow. Then you got to expand this. Now you see why I was getting so mad at the author. This problem goes on forever. You expand this, so you got to cube that out. Now, fortunately, I know some shortcuts. You got to square this and then multiply by this. So I did it in 2 stages. X minus 1 times x plus 1, that's just the difference of squares, no big deal there. But then I have to FOIL this out and collect like terms. Yuck. That brings me down to here. I still have a lot of work to do. You have to distribute all these A, B's, and C's and D's, and then you have to bring everything together in terms of like terms. In fact, let me show you the original here, because I think you can see the color a little bit better. Just give me a little time. So what I did is I kind of color coordinated things. I said, okay, let's put all the cube terms together, and I have all the squared terms together, and then the linear terms, that is the terms in x, together. So you get this huge equation, and then you can come up with your system of equations. Woohoo! It's just by equating coefficients. So that gives you this system of equations, and that's something you can solve with your x inverse or your inverse matrices. I wouldn't expect you to be solving this by hand. I mean, you can. It's not a bad one, but solving it by hand is a real pain. But once you get down to here, it's a matter of equating coefficients. So what could I ask you on an exam? What I've done in the past, I haven't written the exam yet. That's a week away from me now. But what I've done in the past is various combinations of things. Sometimes I'll ask you to just show me the setup. I mean, what you would use. Sometimes I'll give people this much and say, okay, come up with the system of equations. So I would not give a problem like this in total on the exam. It's just a little bit too much, actually a lot too much. I wasn't happy myself solving it. One other note about solving this, and it goes back to our little cover-up method. That cover-up method we use to solve, you might say, well, hey, why don't we just choose a couple of values for x and solve it that way? And you can make some progress on that. If you choose x equal 1, then you can get rid of everything except the d and solve for d. If you choose x equal -1, you can solve for a. But that still leaves b and c unknown. And then what are you going to do? Well, you can't choose 1 and -1 anymore. What you would have to do is plug in what you know for d and what you know for a into this equation, and then choose 2 more values for x. Now I kept them easy, 0 and 2. When you choose 2 more values for x, you get a 2x2 system of equations for b and c, and then you can solve those 2 for b and c. It becomes a real pain. You do still kind of have to know how to equate coefficients, but I'm not going to give you something this long to do by hand completely. All right, so am I clear about my expectations for a problem like this? You should definitely know how to set it up. And if you were given, say, this line down here, you should be able to come up with this system of equations. So you might want to practice at home this part and this part leading to this part. All right, in fact, I think I'll put the original in with the notes. That way you have a good clean copy for that. Any other thoughts on this last one here? It's a real pain one, other than please don't do that to us. But I'm not going to really stick you with a full page of calculations. That's too much. There's a lot on this next test, and I'm not going to concentrate too much on that. Believe it or not, they actually get harder. There's 2 more cases that we're not really doing. So if you think I'm being mean, actually I'm being pretty light, because there's the quadratic case and the repeated quadratic factors. So quadratic case and repeated quadratic factors, case 3 and case 4. So we're really actually taking it kind of light in this section. Let's do problem number 28 real quick. I don't think it's going to be as bad, nearly as bad as the previous one. And what we'll use this to do is to serve as practice for what I would expect you to be able to do. So problem 28 looks like this. 3x squared plus 5x minus 13 over 3x plus 2 times x squared minus 4x plus 4. Now the first thing that you should do in working with this is finish the factorization. Does anyone see what we can do in the denominator? Perfect. X minus 2 quantity squared. So from there, see if you can't write out a partial fraction decomposition. What would you write on the right-hand side? Ruda, what should I write on the right-hand side? Mm-hmm. Perfect. So let's multiply through by the LCD on both sides and cancel out all the denominators so we can start setting up a system of equations here for A, B, and C. So the LCD is going to be basically this denominator here, 3x plus 2 times x minus 2 squared. So I need to distribute that to all four terms here. Now on the left-hand side, when I distribute that, I'll end up with 3x squared plus 5x minus 13. On the right-hand side, someone help me out with the right-hand side. Sydney, give that one a shot. Good. Plus b times, so just one of those will cancel, right? Oh, all right. I'll move on. Lucas looks like he's interested and wants to help out. So b times what?
B times 3x plus 2x minus 2 squared.
Actually, one of those will cancel out, so it'll just be x minus 2. And last but not least, it'd be c times 3x plus 2. Now on the right-hand side here, we got to continue to kind of work with this thing. It's really helpful if you can square out x minus 2 in your head and not get x squared minus 4 or x squared plus 4. What do I get when I square out x minus 2? X squared minus 4x plus 4. If you need to write it out as x minus 2 times x minus 2, that's fine. Multiply it by itself and get this. Now, for the next part.
3x squared plus 6x plus 2.
Good. 3x squared minus 6x plus 2x minus 4. And I'm not going to distribute the c yet over here. We'll just leave it as c times 3x plus 2. I guess there's one last thing that I want to do here, and that is collect like terms in this middle bracket. So a times x squared minus 4x plus 4 plus b times 3x squared minus 4x minus 4 plus c times 3x plus 2. So just clean this up a little bit in the middle bracket. There's two more steps that I need to do. Are we okay this far, though? I don't want to zoom past you and lose you. So what I did is I squared this one out, I FOILed this one out, and then I collected like terms there in the middle. Let's distribute these coefficients now. 3x squared plus 5x minus 13. Ax squared minus 4ax plus 4a plus 3bx squared minus 4bx minus 4b plus 3cx plus 2c. So I distributed everything. Now I want to group together like terms. So notice a lot of you have grown in the habit of bringing extra color pens around. This is a great place for them. I've got a couple x squared terms. Let's bring those together. I'm going to have an a plus 3b times x squared. Let's do the same thing with the x's. See if you can't bring together the x's. So I'll have plus something times x. And the last term is just going to be all the constant terms. And that's going to be kind of everything that's left over. Any volunteers to tell me what's in this middle parenthesis? Negative 4a
minus 4b plus 3c.
Good. Does everyone see where those numbers are coming from? These are all your coefficients of x. Here's all your coefficients for x squared. And the last one, what's left over, those are just your constant terms. So negative 4b, excuse me, negative 4a. Now, how about positive 4a? All right. 4a minus 4b plus 2c. And I probably should have written it in a different order, but oh well. But those are your constant terms. There. 3x squared plus 5x minus 13. Now what I'd like you to do is come up with the system of equations. I'll share with you the solution to that. If you don't feel like typing it in your calculator, that's fine. But come up with the system of equations. Alright, so kind of a lengthy process here. We get 3 equals a plus 3b. 5 equals negative 4a minus 4b plus 3c. And negative 13 equals 4a minus 4b plus 2c. When I first went through this last night and I got my solution, I just couldn't believe it. I'm like, really? So I had to go back and double check everything. But it actually did work out. I did have it right. The solutions for A, B, and C, and I got these off my calculator with an inverse matrix. Negative 135 over 64, 100 over 64, and 9 over 8. Yeah, I was not unhappy about that. Or I was definitely unhappy about that. I just thought that after such a long problem that you should at least give us nice friendly solutions. They didn't. Overall, your final answer would look like negative 135 over 64 over 3x plus 2 plus 100 over 64. I don't know why they didn't put that in lowest terms. I don't know. They left it that way. I'll leave it that way. 100 over 64. If you get this far in a problem like this and you didn't put it in lowest terms, I'm not going to ding you for some points on that one. And then 9 over 8, x minus 2 squared. So, wow. Beastly. For homework, try 3, 5, and 13 through 33. That's section 10.7. Whew. Wow. Get out the oxygen bottle, man. That one's a tough one. All right. Any questions or thoughts to wrap up this section?